Okay, on the back side of our foldable, what we want to understand before we jump into some examples is an idea of an inverse. And we're going to tie this back to inverses that we did in the previous semester when we did the inverse of all of our other functions. So first of all, what I want you to notice is that on both my sine and my cosecant graphs here, what I've done is I have labeled each of the sections on my graphs based on their quadrants that they would be on the unit circle. So this piece of the sine graph would fall into the first quadrant. If we evaluated any angles, this is what we would get. We would get nice positive values. As we moved into the second quadrant of the sine curve, we would still get positive values. As we moved into the third quadrant on the unit circle, we start to get negative values on our sine curve, and then they stay negative into the fourth quadrant. You'll notice that I also gave you the graph moving in the negative direction so that you could see the repetition of the behavior. Did the same thing over here with my cosecant graphs. I've got the quadrants indicated here, but the only thing this graph is going to be missing would be the asymptotes. So we do need to remember that there is an asymptote, a vertical asymptote, right here and right here. So these are important to remember. They'll affect us later. So if we think back to when we did inverses before, what we understood was that the inverse of a graph was a reflection over the identity line of y equals x. So what I've already done is I've already traced my sine curve onto a piece of patty paper here so that we can visualize what's going to happen when we do the inverse of this, when we reflect it over the line y equals x. So when I reflect my graph over the line y equals x, what I can now see is my little s, or my sine curve, is now up and down. And what really should jump out to you is that this graph is going to fail the vertical line test. So if we take the entire domain, the entire sine curve, and we reflect it, we actually don't have a function. That right there is exactly what makes restrictions or makes inverses difficult and causes us to have some special restrictions. So what mathematicians have done is they've said, since the behavior of sine is repetitive, it's cyclical, what we can do is we can focus on just a small portion of the sine graph to create our inverse. Instead of looking at the entire domain, we are going to narrow it down. What mathematicians wanted to do is they wanted to get a piece of sine that would indicate the entire behavior. So we can see that we have portions of sine that are above the x-axis, we have portions of sine that are below. So what we're going to do is they actually have chosen for us this piece of sine that's below the x-axis. They certainly could have chosen this piece way out here in the fourth quadrant, they just didn't. And then they continued that on and chose the piece of sine that was in the first quadrant, which was positive. So this gives us an opportunity to see all the values of sine, both negative and positive. Remember that sine is continuous, so these endpoints are actually inclusive. Now the reason this is going to be important for us is that this piece right here we know mirrors is exactly like this piece out here in the fourth quadrant. They are the same, except for any angles that are in this quadrant right here will be negative coterminal angles for their partners that were way out here. The way that we're normally going to work with this, though, so that we don't have to always look at our graph, is we're going to give ourselves a little visual of this in terms of a unit circle, and we're going to allow ourselves to leave this first quadrant open because, sure enough, that's in our highlighted region. When I move into the second quadrant, I can see that all the points in the graph are not in my highlighted region, so I'm going to restrict that quadrant. I will never choose values or give answers that are in that quadrant. Moving on to the third quadrant, again, not in my highlighted region, so I'm going to reject that. And my fourth quadrant, although it's not highlighted here, it is highlighted here. So I'm going to give myself a reminder that these will be negative coterminal angles. That I can use the fourth quadrant as long as I write it in terms of negative coterminal angles. We haven't done any examples yet. Right now, we just want to get the idea in our head that we can't use the entire sine curve. We need to restrict it down to a small portion. The next thing that's nice to remind ourselves is I can put a solid dot right here to remind myself that that point is going to be inclusive on my accepted interval, and I know that that point is at pi over 2. I also want to give myself a solid dot here on the bottom to remind myself that is also an accepted point, but I don't want to write it as the positive 3 pi over 2. I want to write it with its negative coterminal angle, or a negative pi over 2. So I'll be making reference to this as we jump into examples of this little picture right here. We can do a similar process here with the cosecant graph. You can imagine that if I took all of these pieces of cosecant and I reflected them over the identity line, that once again we would fail the vertical line test. So again, we need to narrow this down to a small portion of cosecant that demonstrates the full behavior. So that full behavior, this gives us a portion that's in the negative interval. This gives us a portion that's going to be positive. And just like with our sine graph, any angles that I use that will be in the fourth quadrant, I'll write as a negative coterminal angle instead of their positive rotation. So we can give ourselves that reminder as well, negative coterminal angles. Again, I can give myself a little picture to remind myself the first quadrant is fine, I leave it wide open. The second quadrant is not in my highlighted interval. The third quadrant is not in my highlighted interval. And then the fourth quadrant is not in the highlighted interval, but instead appears as the negative coterminal angle. So I'll give myself that reminder as well. The other thing that I want to remind myself is that yes, this pi over 2 is acceptable, and my negative pi over 2 is also acceptable. So those are both acceptable angles. We can also remind ourselves that we have this vertical asymptote right here along the y-axis, so we can give ourselves an open circle there to remember that that will not be an acceptable value. And of course that open circle is at 0 radians. If we want to give ourselves a reminder that that's 0 radians. Now, a similar process could be done for all of the remaining trig functions, and I already have those filled out here. So spend some time looking at these remaining trig functions in terms of how did we narrow these down. So cosine, again, I would not want my entire curve. I'm going to narrow it down so I get a portion that's above the x-axis and a portion below. So this time, my two pieces that I'm looking at fall into my first and second quadrants. So when I write that in my notation I used earlier, I'm going to keep the first quadrant, keep the second quadrant, eliminate the third quadrant, and eliminate the fourth quadrant. Secant's going to work in a similar fashion. I need to identify a portion above, a portion below. That will be in my first and my second quadrants that are acceptable, and the remaining ones get rejected. I need to remind myself that this top value here at pi over 2 between the first and the second quadrants, it will be undefined. That's where my asymptote is. But I can in fact include my 0 and my pi for my secant. For tangent, I'm just going to choose a single period of tangent. So that one's pretty easy. I just need to choose one single period of tangent. In this case, it's going to fall in my negative coterminal angles and my first quadrant. So you can see what I've rejected, what I have open for my asymptotes. Cotangent, I once again choose a single period. That's in my first and second, indicate my rejections, and then indicate my asymptotes. So you can spend some time thinking about those, and if you've got any questions, ask those in class. And then if you're okay with these, turn it over, and we're going to do the top two windows of this foldable.